Legos. Searching online, I found the idea to simulate an earthquake using a shake table to test the strength of my Lego skyscrapers. Why do some skyscrapers stay standing in an earthquake? Does a wider base make a skyscraper stronger? Is a base the same width the whole way up? Is it stronger? When I move a Lego building, why does it fall down? And this brings me to my question. Which can stand more force? A skeleton tower, which is this one, or a non-skeleton tower, which is this one, when tested on a shake table? Engineers design many tall skyscrapers. One good example is the Khalifa in Dubai, which stands 2,717 feet. Engineers have to build skyscrapers to withstand earthquakes. A good example is the Pekins Tower in Malaysia, which stands 1,482.94 feet. Engineers use shake tables to test models of the buildings that they want to build. Earthquakes, one of Earth's most destructive forces, create horizontal pressure, causing skyscrapers to collapse. Collapsing skyscrapers cost $2.1 million and 10,000 deaths annually. Earthquakes send shockwaves in short, repetitive bursts. An earthquake occurs when the Earth's tectonic plates get stuck and then suddenly come loose. Tectonic plates are plates in the Earth that move parallel to each other. When the plate moves to the right, it is called minimum force and is recorded in negative numbers. When the plate moves to the left, it is called maximum force and is recorded in positive numbers. First, I had to build a shake table, and this is the shake table that I built. Second, I had to build a skeleton tower, and this is the skeleton tower that I built. Third, I had to build a non-skeleton tower, which is this one, and then I was ready to test them on my shake table. The shake table simulates an earthquake because it shakes like that. And I would pull it back 6 centimeters because I'd use a measuring stick to make sure that I wasn't pulling it back farther for each one. And then I used an app on my mom's phone called the Adreno SJ app, which records how strong the earthquake was and shows it in a graph. Take, for example, this one. This one is the graph, which the minimum is 8.9 and the maximum was 11.8. This was for this one when it fell down. And for this tower, the minimum was 27.7 and the maximum was 10.8. So from this we can see that the one that was 27.7, which is this one, could withstand more force because the minimum, it was a greater number than this one, which is 8.9. My hypothesis was, in a Lego building, I think a building with a skeleton frame is stronger than a continuous floor-block tower. At first, I was confused when I was doing my experiment. First, I thought I was building a tower and testing how high I could build it before it fell down with Legos. But then I realized that Legos can't have a foundation like a real building. So I changed it to which can stand more force, a skeleton tower or a non-skeleton tower when tested with an earthquake simulator. The skeleton tower is lighter, so it has less force being thrown from side to side, which is why I thought it was stronger. I thought it was interesting to learn how a seismometer works. If I do another experiment, I will figure out exactly what I'm trying to figure out. Thank you. And I now stand open for any questions you have.